Hey guys, welcome back. We're talking angle theorem today. Don't even pretend like I didn't scare you. Yeah, I saw you, Kylie. I got Weeberg. She jumped so high. Alright, angle theorem. This is actually a pretty quick and painless episode, so therefore, webisode. Angle postulate. First off, you need to realize that we just finished similarity of polygons. And polygons are not necessarily triangles. Polygons have like 4, 5, 6, 7, 8 sides. And so we learned, remember, there were 2 rules for testing polygon similarity. The first rule, all sides had to be the same. So we needed to test to make sure all sides were the same. These are polygons. And then we had to test the proportionate of sides. And so we had to see if 2 sides were proportionate to 2 other sides of the figure, the polygon. So, understand, all that stuff, it was back. Alright, that's polygons. Multi-sided. Now we're going to be kind of switching gears and focusing in on triangles. Triangles have 3 sides. Place. Alright? Now, triangles actually only have really one thing that you have to test to see if they're going to be similar. Okay, so polygons have the 2 things. All angles the same, and sides have to be proportionate. Right? But triangles have one thing you need to really check, and that is if their angles are the same, they're similar. So we just got to make sure all the angles are the same and we're good. So now angle postulate says if 2 angles of one triangle are congruent, so if 2 are the same, so this is 35 and that's 35 and that's 88 and that's 88. If they're the same angles, then the triangles are similar. And you say, wow, only 2. I don't even need to check the third one. Well, guys, think about it. Okay, if all the sides of a triangle added 180 degrees, right? Then obviously, this baby is going to be the same as this baby because they have to add to 180. As a matter of fact, let's try and slam that out. That's what, 93, 123. So if I took all 2 of these and added them up, that would be 123 degrees. Well, I know each triangle is 180, correct? So I'm going to go 180 minus 123 and 57, I think. 57. So I know this is 57, and guess what? If that's 57, it's the same deal. This has to be 57 over here. Because if I add those up, I'm going to get 123 and blah, 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 blah. Let's get to some action here. Alright, nothing fun today. Nothing fun. Alright, example 1. Determine whether the triangles are similar. So now we're talking triangles. We only have to check that uno momento. 1. That one postulate. 2 angles are the same. Capiche. Capiche. We got similarity. So, determine whether the triangles are similar. If so, write a similarity statement. Explain your reasoning. Alright, so I know this baby is 44. That's 47. Those are not the same angle last I checked. However, this sucker right here is a 90-degree angle. And I say, hey, wait a second. That's a 90-degree angle too right there, right? So now, if I've got a 90-degree and a 44-degree, last I checked that's 134 degrees if I combined them, right? If I combine those 2, it's 134. Now remember, triangles are 180. Let's see if I can squeeze this up here. Triangles are 180, so that means this angle here, question mark, has to be around 46 degrees last I checked. Alright, that has to be 46 degrees. Capiche. So 46. Alright. So if that's 46, hold on. So I have a 44 degree, I have a 90 degree, and I have a 46 degree. Well, my 90 degree angles match up, but the 47 doesn't match up with any of the others. So therefore, no soup for you. No, actually no similarity. No similar. Because I speak no vocabulary. No similar. Alright, fine for you guys who are screaming. Not similar. There we go. Alright. Next one. Alright, example 1. That's right. Did you guys catch that? See? Look. This is example 1. And this is example 1. I'm trying to trick you. Actually, I did this for Emmy. Maybe she would think that we're still on the first problem. I'm kind of wicked today. That was a little low blow. All right. Example 1-2. Determine whether the triangles are similar. If so, write a similarity statement. All right. Well, here's a baby. I got some parallelograms. These are parallel lines. That's what that stands for right there. Parallel. All right. So those mean those are parallel. Thus, we have some parallel statements that I can actually solve here. So, if those are parallel lines, okay, and those technically could keep going on forever out, this looks like a transversal, right? So, I have this angle here and this angle here, and I believe those angles are called corresponding angles, right? So they're called corresponding. And last I checked, corresponding angles were the same. So we know those are going to be the same. And then I'm going to do the same thing here. Alright, so here's another transversal cutting through. Remember, these are my parallel lines here. My cookie fishing. Those are that's my cookie, and here's my transversal cutting through. And I know these right here are actually, well, whatever. They're the same deal. Okay, they're a core as well, so they're going to be the same. But I also know too that this massive triangle. I see we got the big triangle here, the big daddy. And the small daddy. The big daddy and the small daddy. And the small one. Right here, there's the small one. They also have one other angle in common, and that's that baby. So even though I proved those two are similar, or are the same, they're because of, now the name's slipping out of my head. Whatever. I just said it. Correlate. They correlate. Okay, they're corresponding. There, that's the word. That's the word. Corresponding. These are corresponding angles, so I know they're the same. And I also know they both share that angle. Therefore, two angles are the same. And thus, due to angle theorem, these triangles are congruent. Not congruent, they're similar. Similar. Boom. Alright. Now it also says write a similarity statement. So I explained my reasoning behind this, but the similarity statement is basically taking both triangles and saying they're similar. So similarity statement, I'm going to take the big one first. I'm going to start off L, J, JK. I'm going to make this a triangle so I know this is a triangle, right? LJK, that triangle, is similar to triangle LPQ. Right? LPQ. Alright. Here we go. Still on example 1. Alright. Still on example 1. Come on, guys. We've only gotten through one example. How long? Alright, anyways. Determine whether these triangles are similar. Alright, it's parallel lines. Right? This is parallel with this. I always like to do, with my parallel lines, I always like to extend it a little bit more. Maybe it helps my visual. This is a fat cookie. This is like a double stuffed cookie. Look at this thing. Wow. Okay. This is wide. Alright. Double stuffed or triple stuffed, whatever those are called. Alright. 3 minutes left. We got this. We got this, Guam. So, first off, I'm going to take this angle here. Alright. So I got this little tiny triangle here. You know, this angle is going to be corresponding, and this angle are the same. You know why I know they're the same? I know they're the same because we have this thing called alternating interior. An alternate interior, alt-ints, are the same. They equal the same angle. Oh my goodness, we've gone over this so many times. Okay? So alt-ints are the same. Alright, now next. Here's the parallel lines and here's another transversal. So guess what? This angle and this angle are the same because of alternate int. Alright? Alright. I know they're the same because of alternate interior rule. They're the same. Alright. I also know this is the same too. Now I don't need to, remember I only need to prove 2 angles, but I do know S is the same, and that is because of vertical. Right? Vertical. And vertical angles are also the same. That looks horrible. Okay. So actually I proved all 3 are the same. Remember, you only need to prove 2 are the same. And so due to a theorem, we know that these are similar. So I'm going to say, erase all this and make it look pretty here quick. Write this out longer. I can't write it. I'm timed. But the AA theorem, right? Theory. I know that X triangle X R S is similar to, and T, oops, forgot that level. There we go. TWS. Good enough. Okay. Alright. Find X. I think we're going to run out of time, but you should, this is kind of like what we did yesterday. Alright. We're actually told these are similar. Okay. And we're told they're similar because of these proofs. We know these are parallel, and thus those angles and all sorts of stuff. How are we going to set this up? Well, I know they are similar. This is exactly what we did yesterday. It says find X. So here's X right here, right? So I'm going to say X is equal to, alright, now I'm going to set up a proportion because I know proportions work on similar triangles. X is the same thing on the small one as 3.5 on the large one. Right? Now I need to find 2 other sides, and I see this bad boy here. Let me do this in 20 seconds. This guy's 3, right? So I know the X and the 3 is the same thing as the 3.5 and the, see how that's 5 right there? Alright, now it's a proportion, cross multiply, and solve. Bye guys!